I'm Jonghyeon, the first author of this paper, and the topic what we are going to discuss is about dynamic layer skipping for efficient action recognition. With the popularization of camera devices and the growth of video sharing or streaming services, video has become the majority of internet traffic. Therefore, understanding and processing these videos to use them is becoming more critical. So among approaches to video understanding, frame selection methods have one common motivation. Not all frames are important. Below an easy to understand example of these motivations is given. This video is about riding a motorcycle, and you don't need every frame to figure it out. Only a few frames are enough to predict the content. So our research by following similar motifs suggests a different approach. This study assumes that the model will identify significant or overlapping frames among frames in the middle of the CNN model. The example below represents the video frames and the CNN model's layer set as gray blocks. So our research, as expressed in the figure on the right, proposes a model that can focus resources on important frames by stopping the processing on non-core frames in the middle of the CNN. The figure is the overall structure of our model. The example is a video containing the content of preparing pasta. The figure shows that only the frames necessary for the related content were processed to the CNN final layer and used for prediction. And I will tell you more about the configuration of the polish module. There is a LSTM that can utilize the time information and the gating FC that selects whether to stop or forward. At this time, if the result is 0, it makes stop, and 1 is forward. The prediction results from the frames processed to the end are collected and used for the binary prediction. So these are two important losses we used in our model. For one, LCE used for prediction was used. In addition, we adapted G-flops loss to learn the Polish model to make efficient choices. At this time, when selecting forwarding at each stage, the expected G-flops loss are prepared in advance as a lookup table and used in the running process to for example, if the Polish model chooses to forward a frame that is unnecessary for prediction, the accuracy loss and G-flops loss will increase and it will learn to stop the frame. We propose an additional strategy used only in the inference process. We tried it as a conditional early termination strategy based on the assumption that it is predictable even without seeing all frames. It's simple, but it has shown effective results. In this table is the result when compared with existing method. The situation in which input comes in successions is classified as an online type, and the type that cannot process it is called an offline type. In online type, competitive achieve develops and accuracy. The first line of each column is the input frame, and the second line is the processing result. And the number rest is the frame stopped at the locations, and the exceed is the frame not processed by the early termination strategy. So in the case of the third example, carving jack or lanterns in particular, if you're more or less confident in the video, you can confirm that you've stopped the whole process. So to summarize in this study, we propose subnet, an algorithm for effective action recognition. We have shown that the intermediate feature can sufficiently grasp the importance of a frame and stop the operation. So far, thank you for listening to my research.